Welcome to class of physics. In previous video, we studied about the operational amplifier, its ideal characteristics and polarity. So in this class, we are going to study about the configuration of operational amplifiers. So before that, once again, let's see the schematic diagram and polarity of the op-amp. This is the symbol of operational amplifier or schematic diagram. It has two inputs, one is non-inverting terminal and the other one is inverting terminal, and one output. Now if you supply the input voltage to the inverting terminal, then at the output will get the output of different phase, or there is a phase shift in the output of 180 degree with respect to the inverting terminal input. Suppose if we provide the input voltage to the non-inverting terminal, then at the output we will get the same phase output as the input voltage or input signals. Okay, so now go to the configurations. Here the op-amp configurations are classified in two ways, one as open loop and the other one is closed loop. Under open loop configurations, we are going to classify again three different circuits: open loop inverting amplifier, open loop non-inverting amplifier, open loop differential amplifier. Similarly, in closed loop also there are three different configurations. One is closed loop inverting amplifier, closed loop non-inverting amplifier, and closed loop differential amplifier. Okay, so study each one by one. So first, see what is open loop. Here open loop means we are not going to connect a circuit relating output and input, that we call it as feedback circuit. So there is no feedback circuit, there is absence of feedback circuit in the configuration of op-amp. Such kind of circuit we call it as open loop configurations. Okay, one such configuration is inverting amplifier in the open loop configurations. This circuit represents the open loop inverting amplifier. Here inverting amplifier means the input signal is provided to inverting terminal of the op-amp. Inverting terminal means negative terminals. Okay, this is negative terminal, it is positive terminal. To this terminal the input signal is providing, and the terminal, there is non-inverting terminal, is grounded. Then we get the output at the output terminal. Here the output is represented by the negative gain times the input voltage. This is the value of output. The negative sign indicates there is a phase difference in input and output in case of inverting amplifier. That gain is given by minus of V out by V. This is gain of inverting amplifier under open loop configurations, that we call it as open gain or open loop gain. Next, another kind of circuit is non-inverting amplifier under open loop condition. Here non-inverting means the input signal is providing to non-inverting terminal, that is positive terminal of the op-amp. This is positive and this is negative. Now the input signal is provided to the non-inverting terminal, and the another terminal, inverting terminal, is grounded. Then we get the output at the output terminal. The value of output is now the gain times the input voltage. So gain can be written as P out by P in. In this equation there is no negative sign, that indicates both input and output are in the same phases. Next, another kind of configuration is differential amplifier, open loop differential amplifier configurations. So differential amplifier, here we are going to provide the input for both the terminals, inverting and non-inverting. For these two terminals we are providing the input voltage. Okay, V in 1, that is for the non-inverting terminal, V in 2 for the inverting terminal. These two voltages are provided to the input terminal of the op-amp. Then we get the output. The value of output is gain times the difference in input voltages. The difference in input voltages means the difference between these two voltages, P in 1 minus P in 2. Then the gain is given by V out divided by V in 1 minus V in 2. This is gain of differential amplifier under open loop condition. Okay, so this is the open loop configurations. Under this we are going to know about inverting amplifier, non-inverting amplifier, and differential amplifier. And the such kind of configuration is closed loop configurations. Under closed loop configurations, again 3 different configurations. One is closed loop inverting, closed loop non-inverting, and closed loop differential amplifiers. Now let's see what is the output of these 3 configurations and its gain. The first one is inverting amplifier. Closed loop inverting. The name closed loop means there is a feedback circuit. That feedback circuit will relate the output voltage and input voltage, or output to the input terminal. Here the feedback resistor is connected. This feedback resistor is connected between output and input terminal. So usually the input terminal is inverting terminal. Okay. The output is feedback to the inverting terminal of the op-amp. Then such kind of circuit we call as inverting amplifier. Here and the input is provided to the inverting terminal. Okay, now what is the output here? To obtain this, again there is a small derivations by considering the important concept, that is virtual ground. At the virtual ground, the voltage here it is 0. This point we take it as virtual ground as the point of non-inverting terminals. These two now at the same potential, so this point is grounded. That indicates this is also at Vx is also at the 0 potentials. Using this we are going to derive the equation for the gain and output voltage. So Vx is what? It is 0 and Vin is provided to the inverting terminal. Now the current is flowing in this circuit to the feedback path. So in this path the current is flowing. The current is not flowing through this amplifier because the amplifier is having, the op-amp is having infinite resistance. If it is infinite resistance means it can't allow the current through the, for that the current is flowing in this way. Now find the current here. Current through resistor R1 is I. So apply the Ohm's law. P equal to IR. So I equal to P by R. What is P? P is the potential difference across that element divided by resistance. Here the potential difference across these 2 points. So this point is at the input potential P in, and this point is at the virtual ground potential. For that the current I equal to P is what? P in minus Vx divided by R1. So current I is equal to Vx is at 0 potential, virtual ground potential. For that it is P in divided by R1. So call this equation number 1. Now find the current through this feedback resistor RF. The current is flowing in this direction. For that I equal to V divided by V is the potential difference across this resistor at this point and at this point. This point is at virtual ground point and this point is at output point. So here the voltage at this point is VO and at this it is Vx. For that current I is equal to Vx minus Vout divided by Ref. So current I is equal to Vx is at 0 potential minus Vout divided by Rf. For that current I is equal to what? Minus Vout divided by Rf. Call this equation 1. Now equation 1 and equation 2 both are the same values for current equations. For that equating these two, then you get V in divided by R1 is equal to minus VO by Ref. Now gain is what? Gain is V out by V in. Okay. Bring this V in this side, then Rf will go to this side. So for that it is minus of Rf divided by R1. The gain of inverting amplifier under closed loop configuration is minus of Rf divided by R1. This is the gain. So Rf is what? Feedback resistor. R1 is the resistance at input terminal. This is the gain. Rf divided by R1. The negative sign indicates there is a phase difference between input and output because it is inverting amplifier. Okay. Next one is non-inverting amplifier under closed loop configurations. Here non-inverting amplifier means we are going to provide the input signal at the non-inverting terminal. The input is at the non-inverting, the positive terminal. Here we are providing input voltage, but the other terminal, that is inverting terminal, is grounded. But it is closed loop configuration. For that we have to connect the output through a feedback resistor to the inverting terminal. This is feedback circuit. To this circuit we are going to provide the output to the input terminal. Now we have to find the gain of this one. Here the path of the current is in this direction. In this direction the current is flowing. Now find the value of current through resistor R1 and through the resistor RF and resistor R1. And again here consider virtual ground concept here. So this point, now these 2 points are the same potential. Point X and point Y are there the same potential. Now the point Y is at the potential of input V in. That means this point X is also at the potential of V. X is at the potential of V in. So using this value we can find the gain. Now current through resistor RF, that I is equal to voltage divided by voltage potential difference, voltage difference divided by RF. Here the potential difference means across these rays. This is at the potential of output, this one, the output potential V out, minus this is potential of Vx divided by RF. So I is equal to V out minus Vx is equal to the V in divided by RF. Okay. Call this equation number 1. Now find the current through resistor R1. The same current is flowing here through resistor R1. Now find the current at this point. So again I equal to V by R1. So V is potential, that potential difference means potential difference across the resistor R1. This point is at the potential of Vx and this potential is at the ground potential V0. So ground potential V is 0. Okay. For that current I equal to V by R. I equal to V minus 0 divided by R1. Vx is at the potential input potential V1, 0 divided by R1. Call this equation number 2. Now equation 1 and equation 2 are both for the current values. For that equate these two. V in divided by R1 is equal to V out minus V in divided by RF. So mathematical simplification is there. Now solve these equations. V in divided by R1 is equal to V out by RF minus V in by RF. Bring this term into right hand side, then it becomes V in divided by R1 plus V in divided by RF is equal to V out by RF. From these two terms V in is common, so V in is 1 by R1 plus 1 by RF is equal to V out by RF. You add these two terms, then it is V in into RF plus R1 divided by R1 RF V out by RF. So gain is what? Gain is V output divided by V input. For that rearrange this equation. Here V out is there, here V in is there. Bring this to another side, remain to one side. So V out by V in is equal to RF plus R1 divided by R1 RF, this one into RF. These two get cancelled. The remaining is gain. I will write it as AF, feedback gain. RF plus R1 divided by R1. So in this can be written as AF is equal to R1 by R1 plus RF by R1 plus R1 by R1. So AF is equal to, this get cancelled, 1 plus RF by R1. This is gain of this configuration, 1 plus RF by R1. So gain is what? 1 plus Rf by R1 for non-inverting amplifier under closed loop configurations. And next one more configuration is differential amplifier under closed loop. Here differential amplifier means we are going to provide the input for both the terminals, inverting as well as non-inverting terminal. V-in1 is the inverting terminal signal or voltage, and V-in2 is the non-inverting terminal voltage, and this is closed loop. For that we are going to provide the feedback circuit from output to the inverting terminal of the input signal through this resistor R2. Now the gain of this circuit can be written as A equal to R2 by R1 into V. R1 into V difference. It's not gain, it is output. After that we can find the input. V out equal to R2 by R1. What is V difference? That is input differential voltage between these two terminals. So that is V in 2 minus V in 1. Now the gain is V out by V input, that is equal to V out divided by V in 2 minus V in 1 is equal to R2 by R1. So these are the three different relations between gain and input output voltage or resistors, input resistor and feedback resistor. R2 is the feedback resistor. So this is all about the different configuration of operational amplifier. It is open loop, closed loop. Under open loop, three different configurations: inverting, non-inverting and differential amplifiers. Similarly, in the same way, under closed loop there are also three different configurations. So this is all about configurations. We'll stop here. Now take the assignment question. Explain the configuration of amplifier under closed loop and open loop configurations. Thank you.